Hello everyone, welcome back. I am Mr. Cobalt, and today we're going to be talking about solution, concentration, and molarity. Now, when we talk about the concentration of a solution, we're talking about relative amounts of solute and solvent. So let's review what a solution is. A solution is where we have a mixture of a solute and solution, or solute and solvent. The solute is what is being dissolved, and the solvent is what is doing dissolving. And when we're talking about mixing liquids, the component of the solution that we have more of, the majority component is what is the solvent, and the minor component is the solute. But typically we think of solute as what is being dissolved, and the solvent as doing the dissolving. Okay, so that's the solution. It's a mixture of those two things. And so when we're talking about concentration, we're talking about a relative amount of those two things. So you could think of it as like a ratio. So if we think about concentration, right? So the concentration of something is going to be equal to the ratio of solute to solvent. So solvent on the bottom, solute on the top. So if I change the ratio, if I change the amounts of solvent and solute, then I'll be changing the concentration. So the more solvent I have, then the less concentrated it will be. So you can see that there's an inverse relationship between the concentration and the solvent. So more solvent means less concentration. If I do the same thing with solute, if I increase the solute, then I'll have a greater concentration, right? So it's going to be related to relative amounts of solute and solvent. So if I'm comparing different concentrations of things, and I say one thing is more concentrated than another, then I'm referring ultimately to the relative amounts of solute and solvent in the solution, in the mixture itself. So that's really what we're getting at when we talk about concentration. And there are different ways of representing the concentration. How do we represent concentration? We could do concentration in terms of percent volume. We can do concentrations in terms of parts per million, parts per billion, parts per whatever percent. We can think about in terms of percent mass volume or whatever. There's a lot of different ways in which we can represent concentration. A couple of the ones we use a lot in chemistry is one called molarity, and there's another one called molality. Molality we'll cover later, but here I want to talk about molarity because it's so popular, so commonly used as far as concentration goes. So if we understand the concentration as solute over solvent, we could also think of molarity as well. But it's going to be a little bit different. So molarity, which is represented by a capital M, so molarity is equal to moles, and this is going to be moles of solute over liters. Now, you might think liters of solvent, but it's not solvent, it's solution. Liters of solution. So again, the solution here, and it's really important to remember this, is the solvent plus the solute. It's really important to remember that because there may be times where they're asking you questions or giving you problems where you'll need to maybe calculate the mass, or they give you the mass of the solution, and they might give you density or something like that, and you'll have to figure out what the volume of the solution is. So just keep that in mind, that the solution is the solvent plus the solute. Okay, so this is not solvent. Okay, so the definition of molarity, and this is capital M, molarity, is the ratio of moles of solute to liters of solution. And the great thing about this is because we have moles of solute per liters of solution, we have a relationship, and we can now use this as a conversion factor. And it's the same as with density. When we looked at density, density is equal to mass over volume. And so we said, oh, look, we have a ratio, we have something per something, and now we can use that as a conversion factor when we want to convert between between mass or grams and volume in milliliters or centimeters cubed. So anytime you have something over something, a relationship where one thing is related to another thing, you can use it as a conversion factor. And so you're going to use molarity very often as a conversion factor when it comes to concentrations and things like that. Okay, so that's really all I wanted to cover. So in next future videos, I will do more on molarity, and we'll use molarity as a conversion factor to solve problems. I hope this was helpful, and if you like this video, please go ahead and like it, subscribe to the channel, make a comment in the comment section, let me know what you think and what questions you might have, and ring the notification bell so that way you can get notified by any other videos that I put out. Thank you for joining me, and I'll see you next time.